Good afternoon, my YouTube viewers. Crystal here. I wanted to give you another reading, and I wanted to talk to you about Kaggle competition question regarding Ames house prices. Basically, this is an improved version of the video that I gave you this morning because I modified the program, which if you watched the video that I did this morning, you would know that I was speaking about updating my feature selection to see if I could improve the score. And so what I'm going to do is I'm going to give you a video and show you about the feature selection that I did. Now, the score that I received was 13.985%, and that was lower than the previous score, but my accuracy had increased by 1.37%, because on the video that I made this morning and the blog post that I made on Medium, the program that I had used had an accuracy of 94.22% on the validation set. And this accuracy that I have now, after I have exercise feature selection, I have an accuracy of 95.95%. So my score was a little bit lower, but I wrote the program and I trained the program, and according to the train data set, which is what you're supposed to do. So what I'm going to do is I'm going to go through this program with you and show you how the accuracy on the validation set improved. And I can't do anything about the training set because you're not supposed to train the training set. You're supposed to train the train set and test on the test set, which is what I did. So we'll go over the problem statement, which is on the Kaggle website. It says, ask a home buyer to describe their dream house, and they probably won't begin with the height of the basement ceiling or the proximity to an east-west railroad. But this playground competition's data set proves that much more influences price negotiations than the number of bedrooms or a white picket fence. With 79 explanatory variables describing almost every aspect of residential homes in Ames, Iowa, this competition challenges you to predict the final price of each home. Acknowledgements. The Ames housing data set was compiled by Dean DeCock for use in data science education. It's an incredible alternative for data scientists looking for a modernized and expanded version of the often cited Boston housing dataset. So the first thing we did was we imported the libraries, and you can also see the version of the libraries that are on the system. The next thing we did was we imported the data set. So we had a train set, a test set, a sample submission, and a description. Then we loaded the data sets. So we loaded up the train set and the test set. So you can see the train set, and we have lots of cells where there's not a number. So that needed to be corrected. And then we loaded the test set, and again we have lots of cells that didn't have numbers, so that needed to be corrected as well. We looked at the info on the train set. You can see that there's 89 columns. 46 of those columns, 46 of those columns, I believe, 40, or maybe it was 43, was definitely over 40, are objects. So those objects need to be converted to numeric data before the computer can do anything with it. And then we looked at the test set. The test set has one less column than the train set because the test set does not have a sales price column. The sales price column is your target. And so the test set does not have a target because we have to say what the sales price is. They don't give us that information. So we looked at the train set again, and we looked at the test set again. The next thing that we did was we described the target variable so you can see the sales price, and you can see that it's a bit skewed. And you can, if you wanted to use the logarithmic function, you could move it over to the center of the chart if you wanted to. And in one of my programs, I have it moved to the center using the logarithmic function. But not really necessary because that's just a visual representation. So we can see how the sales price increases with the overall quality of the house. And now what we do is we check for null values. And since there were so many columns that had null values, we had to use special coding to make a data frame of just what the null values were. We check the null values in the test set as well. And now what we do is we impute the missing values. And so what we did is we made all of the missing values in mode. And the reason why is because mode is like the most frequently used value. So that's the value that we put into the missing value range. Sometimes you can delete the values, but since this is competition, it wasn't suitable to delete the values. And sometimes you can use median if it's a numeric value, but you can't use median if it isn't a numeric value. So we used mode. So we used on the test file, we replaced missing values with mode as well. On some of these columns that refer to the basement, we just said none to indicate it had no basement. And the other columns that referred to basement, we just said 0 to indicate it had no basement. And then we were talking about the garage. If there were questions relating to a garage, we said 0, which meant that there was no garage. And after we imputed all of our values, we checked for null characters again, and you see that there were no null characters after we imputed all of our values. Now what we wanted to do is we wanted to print off a list of columns that are objects because we were going to need that information. So we printed off a list. I think it was 43 columns when I counted it. So these 43 columns that are objects, we are going to put them into a label encoder, and we're going to do that on the test file and the train file. All 46 files were put into a label encoder. Now what we do is we defined our X, Y, and X variables. So your Y is DF train sale price dot values. Your X and your X test were DF train and DF test, but what we had to do was I was using feature selection to try to improve my score, and so I had to literally go through trial and error with those 80 columns and drop a column, see if it increased my score, increased my accuracy. If it increased my accuracy, then the column stayed dropped. If the accuracy decreased, then I didn't drop the column. And I did that for all 80 columns. Then it didn't go through a standard scaler. I took the standard scaler out. I had originally used a standard scaler and it turned out terribly. Then I used a function called scale and that turned out terribly. Then I used a function called PCA and that turned out terribly as well. So I just took the standard scaler out, and when I took the standard scaler out, it improved my accuracy. Now, what we've done is we've taken our test set and we split it into X train, X val, Y train, Y val, and we split it to have a test size of 0.1. So now what we've done is we've checked our shape of X train, X val, Y train, Y val. So you can see how many rows of data we're going to be trained on and how many rows of data we're going to be tested on. So 14 rows of data were trained on and 146 rows of data were tested on. And you can see that after I did my feature selection, instead of having 79 columns to train, we only had 64 columns to train. So I did my model selection and I chose XGBoost. The reason why I chose XGBoost is because I tried a number of models and the XGBoost gave the highest accuracy, except for a hist gradient boosting regressor came a very close second. But some of the programs didn't work at all, but XGBoost did work. So we checked our accuracy. Our accuracy after we put it on XGBoost with the X train Y train was 99.97%, which is pretty good. And now what we've done is we're predicting on our X val. And when we predicted on our X val, we had an accuracy of 95.59%, which is 1.37% higher than the accuracy that I quoted this morning when I hadn't done feature selection. So now what I did was I made a data frame so you can compare the actual sale prices against the predicted sale prices, so you can see that for yourself. And now what we're doing is we are testing on the actual test file. And after we've tested on the test file, we put that into a data frame. ID is DF test ID and sale price is final labels. After we made our predictions and put it into a data frame, we submit our predictions, and so we create a file called submission.csv, and you get a little message saying your submission was successfully saved. And after we save the submission, then what we do is we upload it so you can see it. So now you can see the actual sale prices that you have predicted that are going to be given to Kaggle, really. And so that concludes this presentation regarding Ames house prices, where we go into feature selection, because feature selection is one way that you can increase your accuracy. And I spent all morning long doing it because I had 80 columns to go through. Well, it's definitely 79 columns to go through because we didn't use the ID column. But we had 79 columns to go through. So it took all morning took all day or several hours for me to go through and test that, because what I would do is I would drop a column and run the program, see if the accuracy improved. If the accuracy improved, then the column stayed dropped. If the accuracy didn't improve, then the column wasn't dropped. And I had to do that, definitely 79 times for the 79 columns. This notebook has been made public, so you can look at the notebook if you want to go over it while you're watching the video. So that concludes this presentation. If you like my video, please like, subscribe, and share. If you have any comments, please leave them in the comments section below. Let me know what you think of this video. If you like the work I do and you want to make a donation, I have my email address to my PayPal account in the description, because I do not make any money on any of these videos that I make because I'm not monetized, and the only way I can get any kind of financial assistance is to ask for donations. And thank you so much for watching my video, and I look forward to making the next one for you.